Welcome back to course Soft Computing. In the previous video we discussed about optimization. We have started a topic of optimization. We have seen what is optimization, why do we require optimization. Optimization is done in terms of resources or time, and there are two categories of optimization we have seen. One is a derivative based optimization and second one is a derivative free optimization. So here we are focusing on the category derivative free optimization. So one of the technique of derivative free optimization is what? A genetic algorithm. So what we understand in derivative free optimization, we understand that in case of derivative free optimization, we are not going to make use of derivative, or we are not taking the derivative of objective function, but we are taking the repetitive evaluation of a same objective function and again unless and until our objective is met. So our objective can be maximize or it can be a minimize. So it is going to vary from problem to problem. So in today's video we are going to discuss about very interesting derivative free optimization technique, that is genetic algorithm. Now let's start genetic algorithm. So here we are going to understand in detail what is genetic algorithm, what kind of different concepts being used in that genetic algorithm. We'll discuss along with the example. So now let's start the concept of genetic algorithm. So what is genetic algorithm? As genes, have you heard about the genes? What is the use of genes? Where you heard? Actually the genes is a terminology that you may heard in biology. Suppose you have opted bio in 12th, then you are aware about the genes. So for those who don't know about gene, I will tell you in simple way what is gene and what is the role of gene in our body. Just like that, we are saying particular person is long, particular person is short, particular person is thin, particular person is fat, particular person is having very good eyes. So why this particular person is having curly hair? It is just because of the genes. In our body there is a chromosome, and in that chromosome there are n number of genes are there. So gene is responsible for various features of our body. We have very long somebody is having very long hand, somebody is having short hand, our hair, eyes, nose, ear, all these are represents our gene. Means from our parent we derive some features from our parent, but in our body still there are new features are there, because every time it is not possible that you resemble your feature should resemble your each and every feature should resemble with your parents. Sometimes some features, maybe you heard about that particular boy is just looking like his father, his hair is just like her mother, his eyes just look like his father, like that. Means these genes are responsible for that. So genetic algorithm is one of the concepts that is inspired from the term of biology. That's why we are saying that genetic algorithm is a bio-inspired algorithm. It is based on the evolutionary theory of survival of fittest. So we already know the Darwin's theory of survival of fittest. The person who is fit, that will survive, the person who is not fit, that will not survive. So genetic algorithm is one of the concept that is derived from the concept of Darwin's theory of evolution, that is survival of fittest. So what is the basic use of a genetic algorithm? Genetic algorithm is used to find the optimal solution, or it is used to find high quality optimal solution for various problems, because we need to there are n number of problems are there for which we need to find the solution, and for one problem n number of solution exist in the environment. We talk about the search space. In the search space n number of solutions are already there, so we need to find that solution. So genetic algorithm help us to find high quality optimal solution for various problem, and it is in the category of evolutionary algorithm, because evolution has been takes place where from a parent their offspring is generated, then again from that offspring another offspring is generated. So in this way the concept of evolution is being there. So genetic algorithm, we can say it is a evolutionary algorithm. It is used to find high quality optimal solution. Okay, and this genetic algorithm involves n number of new terms that we are going to discuss over here, and it involves various operators such as the selection operator, crossover operator, and mutation. These are the three main operator is in the category of genetic algorithm. So we will see how that selection process works, how that selection operator works, how crossover operator works, and how mutation operator works. So we'll discuss all this thing. Now these are the various terms that is being used in a genetic algorithm. So in case of genetic algorithm, population means what? Group of individual. So group of individual together to form a population. Means main term is what? Individual means what? Particular element, and group of elements together it forms a population. Then genes, just I told you, gene is responsible for various characteristics of a human being. Fitness, just we talk about survival of the fitness. So fit means in order to means our objective, particular objective is there, and for which that particular individual is fit or not. Just take a simple example. I need to select one candidate for my company. So in that case I need to evaluate the fitness. So fitness is in terms of what? In terms of technical skill. Suppose 10 students are there who are appearing for interview, and I need to select only one student. So obviously I will select only one student who is having a excellent technical skill. So in this case we can say that their fitness is represented with the help of technical skill. So that is going to vary from problem to problem. The meaning of fitness is going to vary from problem to problem. In this case my problem is to select only one student for my company. So in that case fitness is what? Technical skill. Technical skill is a fitness. Then there is a selection operator. Obviously you need to select those individual who is having who is fit, who is totally fit. Fitness is important. Then crossover is there. Crossover we'll discuss in detail in next slide. What is a crossover? So actually in the crossover, parents comes together and they fuse together to form a new offspring. Without crossover, new offspring is not generated. In order to generate a new offspring, crossover of parent is important. Crossover means what? Fusion. And mutation means what? Mutation is the process where we introduce a new kind of gene. Just like that, offspring is generated from the parent. So that offspring somehow similar with the father and somehow similar with the mother, but there are some features which are new in that offspring. So why this thing is happening? Thus because of mutation. Mutation means what? We are introducing some new feature which is not present in the parent, either in the father or either in the mother, but a new feature is being arrived in that particular child. So this is called as a mutation. And offspring means what? Just like that, from parents a new entity is being generated and that entity is called as a offspring. So these are the various terms which is being used in case of a genetic algorithm. Now we'll see the crossover, what exactly the crossover operation is. And one more term we need to see here. In case of genetic algorithm, mostly we are dealing with a binary encoding. Binary means what? So here you can see we are making use of a binary encoding. That means it is in this case that genes is represented with the help of 0 and 1. Okay, that's why you already know about the binary value. Binary represents 0 and 1. 0 1 means what? Binary. So in this case we are making use of binary genetic encoding. That means it is represented here, genes is represented with the help of zeros and 1. So we are talking about crossover operator or crossover operation. Crossover operator and operation play very important role in case of a genetic algorithm in order to produce a new offspring. In order to get new offspring, our intention is very clear that we need to generate a new offspring so that new feature will be there in the offspring and offspring is better as compared to his parents. So in crossover operation we are fusing two parents so that we'll get a new offspring over here. So there are three types of crossover operation is there. One is a single point crossover, 2-point crossover, and multi-point crossover. Now in order to illustrate single point crossover, I will take a simple example. Now this one, S1 is one individual and S2 is another individual, and this S1 is represented by this binary genetic encoding 101001110. This is what encoding used to represent individual S1. This S2 is another individual. We can say that S1 and S2, these are two parents. Now for this we need to perform crossover operation, and what type of crossover we are performing over here? Single point crossover. So I just drawn this line. K1 is a single point crossover. So what we need to do over here? So we need to keep this 1 0 as it is. So here I have formed single point crossover. This is a single point, so all the bits which is present on left side of this point I will keep as it is, and all the bits which is present after that particular line on the right hand side I need to flip it. Okay, so suppose I apply 1 point crossover on S1 and S2. After doing this I will get this new. So what I have done, 1 0 remains as it is, but this 1 0 1 0 is replaced over here. That means I have done the flip operation over here. 0 1 0 0 1 1 0 you will find over here, and 1 0 1 0 you will find here. So this is what a single point crossover. Now second type is a 2 point crossover. That means here we need to take 2 points. This is point K1 and this is point K2, and randomly you can take point anywhere. It's a random process. It's not like that you need to take like this or that one. It is going to vary from person to person. So in case of a 2 point crossover you need to establish a 2 point. This is point 1 and this is point 2. Again, two individual we have to take. One is S1 and another is S2. Now we need to take the crossover, 2 point crossover. So what we'll do in the crossover means before that point whatever the bits are there we'll keep it as it is, and on the left hand side, on extreme left and on extreme right, we need to keep all these bit as it is, and the point which is present between that particular two points we need to flip it. That means this 1 0 will remain as it is, this 1 0 will remain as it is, this 1 0 1 0 remain as it is, but only this 1 0 and 0 1 gets flipped. So 1 0 is replaced over here and 0 1 is present over here. So this is called as a 2 point crossover. Now similarly we have third type, that is multi-point crossover. So in this case we have total 3 crossover point. This is 1, this is 2 and this one is 3. So in this way, in this case what you need to do, you need to do the flip operation alternately. So in this case, first of all what you'll do, you just flip the values. So here 0 is flip here and 1 is present over here, you can see. Then after that 0 0 remains as it is. After third again flip, 0 1 is replaced by 1 0, so 1 0 is present over here, 0 1 is present over here, and after that again not flip. That means we'll keep this point as it is. Okay, so this is how multi-point crossover operation works. Okay, see actually I think here flip, no flip, flip, no flip. Here 1 1 should be there, but by mistakenly I have written 1 0. I apologize for that. So here 1 1 and here 1 0 should be there. Okay, so this is what a multi-point crossover. Now next we understand how mutation operation is going to be performed. So in case of mutation operation, what exactly we are doing, we are trying to introduce one or more random bits and we need to flip them. I have just marked over here, I have just taken this individual S1 as an individual and I need to perform mutation operation. So in case of mutation operation, what exactly I am doing over here, I am selecting one or more random bits and I am flipping them. Flipping means what? I need to flip between 0 and 1. Suppose I found 1, I need to replace it with 0. Suppose I found 0, I need to replace it 1. This is what a flip operation. So in this particular individual, I have selected this 3 bit for flipping operation, and that is a random procedure. It is not a case that why you have selected this one. So here the first 0 will remain as it is. As I selected this for flip, so 1 is replaced by 0, then 1 is replaced by 0, and this 0 is replaced by 1, and this 2 1 1 remains as it is. So this is what a mutation operation. See why I am explaining this crossover and mutation, because in order to explain the example of genetic algorithm, we need to understand how to perform crossover operation and how to perform mutation operation. That's why I explain this procedure completely. Next is phases. What are the different phases involved in genetic algorithm? And genetic algorithm is iterative in nature. It's a iterative procedure. Iterative means what? We are just doing the number of steps again and again. So what are the steps that is involved in genetic algorithm? Very first one is population. Just we have seen what is a population. Population is nothing but a group of individual. Individual means what? A particular component. Suppose we are taking the example here in terms of human being. So we can say one human being is one individual, and when group of individual comes, it becomes a population. So that terminology is going to vary from problem to problem. It's totally depend on what kind of problem that you are considering over here. So population is nothing but a group of individual. After that, what we have, after that we need to calculate the fitness evaluation. Means we need to calculate the fitness. Just I explain you what is fitness. That fitness is going to differ from problem to problem. Now just I given the example of selecting a student for a company. So in that case, fitness is nothing but a technical skill. So for each student during the interview, I need to calculate the fitness or technical skill. A technical skill of that student is this. Finally, I'll just go through this. Obviously, I will select those student who is having a highest technical skill. So this is what the evaluation, fitness evaluation. First of all, initial population is being generated, then their fitness value is calculated. After that, selection operation works. So obviously you will select only those individual who is having a highest fitness value. I will select those individual which is having a highest fitness value. So this is what a selection phase. After selection, there is a crossover. Just we have seen crossover is the process of fusing two parents, so that we need to form a new offspring over here. And crossover can be performed by using various operations such as a single point crossover, 2-point crossover, 3-point crossover. After that, there is a process of mutation. So what is mutation? Mutation is the process of introducing a new gene into offspring, so that we will get variation in the offspring. What we want that from the parent, the child should have some new feature which is not present in the parent itself, and this is happening just because of mutation. So this is iterative process. Again, you need to check a population, again you need to calculate the fitness, again you have to perform selection, crossover, mutation, population. So this process continuously happening unless and until we will get our objective. So here we are going to discuss one example, that is a max 1 problem. Okay, so what is a max 1 problem? I will explain over here. So then I will explain the algorithm. First of all, we discuss the example as usual, and then we study the algorithm, because it's easy to understand algorithm with the help of example. So what is max 1 problem? So max 1 problem is very simple. We want to maximize the number of ones in a string of binary digit. Suppose we toss a coin for 60 times and get the following initial population. That means the procedure is simple. I have one coin and I need to toss it for 60 times. So what, for that purpose, I divided it into 6 sets. In one set, I need to toss a coin for 10 times. Similarly, in another set for 10 times. Likewise, I have total 6 sets where I need to toss a coin. And in this case, one represent tail and 0 will represent the head. Okay, head and tail is represented. So why we call it as a max 1? Because we want that we should get maximum number of tails over here. So apply the genetic algorithm on the initial population to get total 38 correct answer as a tail. That means what is the objective of this problem? Our objective is to maximize the number of 1. And what is that 1 represent? 1 represent the number of tails. That means I need to generate maximum number of tails, and its value is given, that is 38. So in case of genetic algorithm, termination condition is very important. So in this case, termination condition is decided based on 2 criteria. One criteria is what? Number of iteration, that for how many iteration you need to apply this algorithm. And second termination criteria is that you need to have some objective. That means in this case, our objective is to get total 38 number of tails. Currently in this problem, in initial population we have 33 number of tails, but our objective is to get 38 number of tails. So unless and until I will get 38 number of tails, I will continue the process of a genetic algorithm, where we have seen population, fitness evaluation, selection, crossover, mutation. So this process we need to continue unless and until we got total 38 number of tails. So in case of genetic algorithm, you need to understand that there are 2 terminating criteria can be there. One is number of iteration, and second one is what? To satisfy a particular objective. That can be a maximize or it can be a minimize. So this is the initial population. So in step 1, you need to consider initial population. So S1 here I written as it is, and here f of S1 is nothing but a fitness value. How fitness is calculated? Number of ones, because I told you that in each and every problem fitness is different. different. So in this case, fitness is nothing but how many number of ones we are getting. 1 means what tail and 0 means what head. So in this case, my problem is to maximize the number of ones. So in this case, fitness is evaluated based on number of ones present in that particular set. So in this case, I have total 6 set, or you can say 6 individual. When this 6 individual or 6 set comes together, it forms a population. So here I have calculated the value. This is what the initial value. Suppose I sum up this all this value, you found that its sum is 33, but my objective is to maximize the number of ones to 38. So for that purpose, I need to apply genetic algorithm. Now step 2 is selection. So obviously this fitness value is there. So which individual you will select for the process of crossover, for the process of fusion, which 2 individual you will select? Obviously you will select only those individual which is having a highest fitness value. So in this case, highest fitness is 8, that is S5, and second highest is S1, that is with a fitness value 7. So in case of selection, I will select these two. One is S1 dash and second one is a S5 dash. S1 dash and S5 dash, these are the 2 individuals which I have selected from initial population, and the selection criteria is maximize the fitness value. So in this case, highest fitness value is 8, second highest is a 7. After selection, next is a crossover. So I need to perform crossover between these two. Rest of the individual I need to keep as it is. Only I need to perform crossover operation between this 2 individual which I have selected, because I found that these 2 set are fit for crossover. So here I have selected. So here I am using 1 point crossover, because here you have seen only 1 point is there. We know that there are 3 crossover operation, 1 point, 2 point and multi-point. So here we are using 1 point crossover. So in 1 point crossover, we need to keep left hand side bit as it is, and we need to flip the right hand side bit. So here S1 double dash and S5 double dash. So S1 double dash is what first 3 remain as it is, and then this one is replaced by this one. So here 0 1 1 1 0 1, and similarly for S5 double dash, first 3 1 remain as it is, and this one will be present over here, 1 0 1 0 1 0. Okay, sorry, 1 0 1 0 1 0 1, like this. So we have found S1 double dash and S5 double dash. So S2 S3 S4 S6 remains as it is, because they are not fit that much fit as compared to S1 and S5, so they are not selected for the process of crossover. No, crossover is being takes place between S5 and S dash. After that, you need to perform mutation. So this is what input that we have given as an input to the mutation operation. So in case of mutation, what exactly we are doing? We are randomly flipping the bits. Flipping the bits. That means we are moving 0 to 1 and 1 to 0. So here below whatever bits I have just marked it, that means I have selected this bit for flip. In S1 double dash, I have selected this 0 for flip, this 1 for flip. I have selected 2 bit from S1 double dash for the process of flip operation. So rest of the bit remain as it is, only this 0 is replaced by 1. Here you can see this 0 is replaced by 1, and this 1 is replaced by 0 over here. Okay, so this 1 is replaced by 0 and this 0 is replaced by 1. Similarly in S2 dash, I have selected this 2. So here instead of 0 I have 1, instead of 0 I have 1. So for this 2 bit I have selected and replaced it by 1. Similarly in S3 I have replaced this 0 by 1 over here. Here you can see. Then in S4 I have selected total 3 bits for the process of flip. So this 2 0 is replaced by 1, and this 1 is replaced by 0 over here. Okay, then in S5 double dash I have selected this 2 bit, this 0 and 1. So here 0 is replaced by 1 and 1 is replaced by 0 over here. And similarly for S6. So similarly I got S6 dash. So this is how the final population I have generated. Now again we have to check the fitness of that. We need to check the fitness. We need to calculate it. Now we have calculated 8 7 7 5 7 4. This is the fitness of an individual set, and and finally you have to do the sum. So in this case you find the sum as a 38. That means your objective is what? You need to get maximum number of 1, then that is equals to 38. Now in only one iteration we got this, we achieve this output. Maybe the case that in this case our objective is to get the number of ones equals to 48. So what you need to do after that, again you need to do the same steps. You have to repeat the same step. Again you will go for selection, again crossover, mutation. So selection, crossover, or mutation, these are the 3 steps which you need to repeat again and again unless and until you met the terminating condition. Terminating condition is either number of iteration or desirable output. So in this case our desirable output is 38, so we will stop here over here. So this is how you need to solve a numerical based on genetic algorithm. So here we discuss one problem of max 1 problem. Okay, similarly you need to solve another problem also. So this is what an example. Now let's look at the algorithm. Now it's very easy to understand algorithm. What is step 1? Initialize a population with randomly generated individual and you have to evaluate the fitness value. What we have done, we have generated the initial population and we have also evaluated their fitness value. So this is what step number 1. In step 2, select 2 members from population with highest fitness value. Here you can see we have selected S1 and S5 as a 2 individual for the process of crossover. This is what your step number 2. Select 2 members, then apply crossover operation. We have selected S1 and S5 and we have applied crossover operation. Okay. Then apply mutation operation. After crossover we have applied a mutation operation over here. Here see, mutation operation we have apply. Then repeat A to D until enough member generated to form a next generation. That means this process will remain continuous. Selection, crossover, mutation, selection, crossover, mutation. This is what a repetitive process that you need to continue. And in this case what we have written, you have to continue repeat the step 2 and 3 until stopping criteria is met. And just I explain you what is a stopping criteria. Stopping criteria, first one is number of iteration and second stopping criteria is desirable result. In this case, in our example, desirable is what? 38. I need to get maximum 38 in this problem. Then and then I can stop. So this is how genetic algorithm can be used to find the optimal solution for a given problem. So I hope you understand what is the concept of genetic algorithm and how to solve a numerical based on genetic algorithm. Thank you.